Welcome everyone. I'm Colin Simpson and this is the July webinar for the TELEdvisors Network. Today we are going to be having a look at HyFlex Teaching, what happens behind the scenes, and our presenters are a range of learning designers, academic developers, education technologists from around Australia. Just as a quick introduction, if you're not familiar with the group, TELEdvisors Network is a community of practitioners made up of people working as education technologists, learning designers, academic developers, and in a host of similar roles. So I might now introduce our first presenter, Michael Crocco. Let me stop sharing. Michael has a Bachelor of Science in Mechanical Engineering from the University of New Brunswick and a Master of Teaching at Deakin, 15 years of industry experience as an automotive design and evaluation engineer, and he is currently a Senior Educational Designer with a focus on technology in the Faculty of Engineering at Monash University. So are you good to go?
Yeah, I'll just share my slides, make sure they're up and running. Great. So thanks for the opportunity to speak today. I'm going to walk you through a little bit of the development that we've been doing since obviously our kind of being thrust into hybrid teaching early in 2020. At that time, I was actually teaching at the university as opposed to employed as an educational designer. But I kind of took on a role to assist a lot of the design teaching that I was doing in that transition, and essentially built myself a position out of that sort of happenstance. So just briefly, a few different topics today. I'll touch briefly on these sort of bullet points. First one being how we adapted our active learning model for the hybrid classroom. And look at, because so much of the work we do in engineering, and this may or may not be applicable to everyone here, so much of the work that we do is teamwork based, and just kind of some of the strategies we developed around that and some of the kind of standards of practice, I suppose. And if we've got time, I might have a brief word about digital assessment, because we've also found ourselves, as a result of this change, it's not necessarily directly related to hybrid teaching, but we found ourselves needing to do more digital assessment and speak to the items that we've kind of adopted there. So active learning, again, primarily focused on design. We obviously had a scenario before the pandemic where students would come in and be able to build their own designs in student workshops. Those were obviously shut down. And while we still had the need for those projects to occur, we tackled it in a few different ways. So initially, obviously, when everybody was off-site, we developed some workarounds there, and I'm getting ahead of myself a little bit here. But what we've landed on now, where we have a number of students remote and a number of students on campus, we're rethinking, I guess, a little bit more guided learning in the teamwork process, where students, specific specialist roles are developed for students who are off-site. That's, as just an example, they might fulfill a project management role, whereas normally we allowed students to kind of gravitate toward those roles as needed. We've been a little bit more prescriptive there to encourage them to have a high degree of influence, because we feel that a lot of the remote students can get left behind in this process. We've also kind of scaled back some of the projects that we've done, not scaled them back in terms of the learning, but we've maybe simplified them to make them something that can be done in the home. You can see the image here on the left. Hopefully you can see my cursor anyway. On the left here, we've got students who are building things out of simple and available materials, things that they could get at Bunnings, for example. So we stepped away from the kind of light metals and those sorts of things, because ultimately those aren't crucial to the engineering process, and so we focusing on available materials and really orienting all the project work toward process following, as opposed to, for example, ultimate strength of their design outcomes. The other thing we did, for example, and I haven't got a picture of it here, but for students doing mechatronics and electronic work, packaged up a lot of kits and shipped them out. So every student who is remote now receives a care package, as it were, with all the kind of equipment, soldering irons and multimeters and electronic devices that they need to do to have the same experience that they would in the lab here on campus. The other thing that we did was where the labs have, sorry, not the labs, but the workshops have been, in various states of open and close. We've had expert technicians be able to be on site and essentially work up a consultative process with students where the student design is presented to that expert technician. That technician builds and does detailed sort of video feedback of the build process and a reflection, I guess, piece. Often what we find is, the benefit of hands-on learning is you find out that your design was wrong and how it has to be changed. But of course, if you don't get to close the loop there, that learning is lost. So we essentially had a stand-in for the student experience and tried to, I guess, provide as detailed a feedback cycle as is possible. Those are some of the large steps we took in terms of that hands-on learning. The other item, I guess, that we've had to contend with is teleconferencing in that practical classroom. Obviously, it's reasonably straightforward in places like lecture theaters and, when students are working at desks, but working in the practical space, be it, I guess, even computer labs, but also physical hands-on, as well as even just work on whiteboards in groups. We've had to adopt some practices that, I guess, as a faculty. One of the things that we did was to talk about the digital space as though it were a physical one. This is maybe a small thing, but we found it reasonably helpful in a lot of cases where we would talk about, for example, in breakout rooms, to not use the terminology breakout rooms, but to talk about them as clustered desks or something similar, and that the academic would, or the demonstrator would, walk around, which means, of course, leaving one room and entering the next. That kind of language, I believe, was helpful to both reorient the academic and to kind of maybe provide some consistency of experience to the students as they're displaced. Another, I guess, item that we had to deal with was we still had, when academics were teaching on campus, a desire for them to work in physical media, be it, again, actual physical whiteboards or something like that, and that the remote students could just use electronic solution. Might seem a simple thing, I suppose, but kind of mandating the use of digital tools was important to involve those remote students. So even if there was a physical whiteboard available, we basically pushed everybody on campus to use a digital solution. I don't know how interesting it is, but one of the things that we did was spend quite a bit of money on having a stockpile of cameras and kind of various arms and mounts for cameras and things like that, and found that within using Zoom and some expertise around multiple camera use, we were able to kind of improvise document viewers, and we had people with cameras on their chest as they walk around. For example, there's a unit where we do some sewing, and obviously to experience what's happening on the sewing machine, you really need to have a first-person view. So the academics and demonstrators having chest cams, for example, allowed the remote students to get that direct experience, or as close to it as possible, and to not be left out of the room, essentially. We had a lot of room AV in place that was not suited to the deployment on Zoom, and so we made a lot of sort of temporary solutions, I guess some of the things I've already talked about, and then eventually worked with our IT department to develop new ways to leverage existing equipment, I guess, for a rich Zoom experience. We have a few facilities that are dedicated to live stream video and live stream teaching, but being that we had to achieve that similar end in almost every teaching space on campus, that needed to be an improvised and I guess refit without outlaying some of the, some of these systems are $150,000 per room. We obviously didn't have that kind of budget, so we worked a lot to set standards and targets for those sorts of systems. Another thing, and I'll show a picture of it briefly later, is just having things like large monitors on wheels and a lot of webcams and things like that to try to develop some ways of delivering that hybrid experience. As I mentioned before, teamwork is a big, I guess, mandate in engineering instruction. And I guess I'll just speak to a few of the items that we found there. There was a desire from academics to have homogeneous groups, meaning a group of students that is all on campus and then another group of students that is all off campus. The university policy is essentially to provide a comparable experience to remote students, and so we, early on, more or less mandated mixed groups and worked a lot of hand in hand with academics to develop how that workflow is going to work, what the norms of the classroom are going to be across that really quite difficult to do mixed grouping. That involved a lot of careful management of how breakout sessions work. It's really easy for that remote student or two within a group of 4 or 5 to be lost or left behind. And so that meant some things like clear expectations and role development, as we talked about before, as well as really careful etiquette around the use of Zoom and how headsets work to avoid things like feedback in the rooms and these kind of things. Again, these seem like small things that everybody should have a grasp on by now, but really it's not the case. And the training was instrumental, I guess, in allowing those initial classes to go smoothly. As everybody likely knows, you can lose a class cohort very quickly, and so having really clear guidelines and instructional material was important for us. There's in agile project management and engineering in general, the stand-up meeting is pretty, I guess, standard, and it can be difficult to achieve across the digital divide. And we made sure that basically stand-up meetings became more regular and I guess more focused upon in most of the teamwork deliveries that we did. Collaboration, we've basically I'll combine collaboration and templating. Found that it was very, very helpful to use the Google Workspace, which used to be called G Suite. I noticed that that's just recently changed. With both provision of templates to the students, but at very minimum, the creation of a drive structure, which can be audited. We're actually looking at how that now can be integrated with Moodle, and that's one of the tasks I'm looking at in the coming months. But having that consistent space for students to collaborate was important. In past deliveries where we were all on campus, we allowed students to have a bit more autonomy there and to have a meeting and discuss how they were going to do it. Unfortunately, we didn't find that worked initially, where if the majority of students were on campus, they might gravitate toward a system that works more, is better suited to them. So basically, dictating the space in which they work was an important one for us. Just a quick word, I guess, on Google Drive and Google Workspace. We have the I don't know if everybody's used it, but when a document is created in Google Docs, you can see the edit history. So able to drop into these documents, see who's engaged, see who's disengaged, how often they're making edits to these long-term project deliverables, and basically early intervene where remote students are somehow being left out of the process. And they, with a similar bent, having clear meeting minutes with deliverables from students. While it was something that was done in limited cases before, really focusing on that again and ensuring that participation we found to be really important. This is a quick view of one of our teaching spaces here. It's not the best view of it, but this is a 320 seat space in our new Woodside design and build technology engineering and design building. And so we've recently developed this system where we have monitors on wheels. The view here is that each of these desks is a team, and that the remote members are able to join on the larger monitors that we provide, instead of them being kind of stuck in a corner on somebody's laptop if they care to do the work. So when we're having, as I mentioned before, stand-up meetings, you've got an auditing demonstrator able to speak to those remote students kind of on a similar playing field, I suppose, to the ones that are face-to-face. Again, as opposed to them being, a portion of a smaller screen, they can be more front and center while they're presenting their document. This is just being deployed now, but this is one of the things we've been working on and sort of trialing on smaller scale. If we've got time, I'll just go through my digital assessment and then take any questions that you've got. So one of the things that, as I mentioned, we found ourselves having to assess digitally, and we've been doing a lot of work in that space. We had existing tools. Essentially, we're on the Moodle LMS, which has a few means of assessing students, but we really needed to exploit them to their kind of optimum and understand how well we can assess on those platforms. That meant developing a lot of UI and UX improvements to create question code. So we have now a number of sort of focus systems to capture the information from the academic and auto-generate larger codes for questions that enables more accurate assessment, more detailed assessment, and things like that. It's another thing we do is share successful workflows and have regular kind of information sharing and promotion of workflows that have been developed by other academics. A lot of training and kind of I guess one-on-one work about rethinking questions and how to invert the questions that we ask. For example, in engineering, one example might be draw the graph that this system creates. That's a really hard thing to automatically assess, and it's a hard thing to capture digitally. So we talk about, well, can we, for example, present the student with a graph and then have them define the system that creates that response, for example. So a lot of kind of coaching work around that. And I guess the bulk of my work now in the role that I'm in, probably more than half of it is looking forward. We know we're going to be in the space basically forever now, and we need to ensure integrity and basically higher level assessment. And we've now, in this environment, redoubled our efforts, or possibly several-fold folded our efforts in this space. I don't think I'm over time there. That's basically what I had to say, but I'm happy to take some questions, I guess.
That's phenomenal. Thank you so much, Michael. I guess I'm curious to know how the students and how the lecturers have responded to this. How do they feel about it in terms of the quality of learning and teaching?
Yeah, it's been interesting. I mean, simple response is probably a mixed bag. We've seen, a lot of people are obviously not feeling great about the absence from the classroom, but anecdotally, because this is essentially how we tend to analyze these things. We use SETU, but we look at those verbatim comments by students, and some of them initially were focused on the gap in experience, but we've seen a lot of anecdotal evidence from students that they are very appreciative of the effort, especially in those design units, which require so much collaboration and so much sort of invention on the part of the students. I would say that the mode has been a recognition that we're doing the best with what we can and that the learning outcomes were met. Academics, on the other hand, maybe not on the other hand, but there's been a big learning curve there, I think. I mean, a lot of people were used to doing things, the way they had always done. There's certainly been a technical learning curve, but I think the educational outcomes have been generally well, I guess, adapted to this mode. And we were already doing things like flipping classrooms and things like that, which honestly helped a lot because we were already had that foot in the digital space and requiring work from the students in their homes. So that perhaps assisted things a lot, I guess. The additional lot, I should say.
Oh, and obviously, yeah, we're in a situation where this has kind of been thrust upon us in many ways. So it's yeah, it's not something necessarily anyone would have chosen to do, but I think it's led to a flowering of some really creative problem solving.
As an engineer myself, I worked in automotive for Japanese companies throughout my entire career, but never in Japan. I had a lot of experience with remote working and working across that divide. And I think, a lot of the coaching was, this is what will be expected of our engineers. Now, I don't know how ubiquitous that is across different disciplines, but certainly for engineers, they're working digitally all the time anyway. So this was early on seen as a need for the students anyway, and probably an area where we may have been letting them down previous to this. So, I think the faculty itself has seen this as, yep, actually probably something we should have been doing anyway, and so the push is one that we would stick with, even if everything went back to normal tomorrow, I think.
Yeah, fantastic.